You're welcome to Educational World. In today's video, we are looking at a typical likely question for WAEC 2020 Physics Practical Number 1 question. If you're a new viewer, I would like you to subscribe, like and share. And if you're a student out there that is smart, I would like you to listen carefully and watch this video to the end. This question is first of its kind, and I drafted it out from the requirements of the WAEC white paper. I read the instructions. You are provided with a uniform meter rule, a rotor stand, masses, and other necessary apparatus. Suspend the meter rule horizontally on a loop from a clamp of the rotor stand and note the position of the loop as the center of gravity of the rule. Keep the loop at this point throughout the experiment. Suspend the object labeled MX at the 20 cm mark of the meter rule. Suspend a mass M, which is equal to 40 grams, on the other side of G. Adjust the position of the mass until the meter rule balances horizontally again. Read and record the position W of the mass M on the meter rule. Determine and record the distance Y between the mass and G, and also determine and record the distance X between MX and G. Repeat the procedure for 4 other values of M, which are 50, 60, 70, and 80 grams. In each case, ensure that MX is kept constant at the 20 cm mark and the loop at G. Evaluate the inverse of Y in each case. Tabulate your readings. Plot the graph of M on the vertical axis and the inverse of Y on the horizontal axis. Determine the slope X of the graph, and lastly, evaluate. So with that in mind, what is clockwise moment? Clockwise moment is just the mass, the given mass M times the perpendicular distance from that M to the center of gravity G, which is equal to Y. The anti-clockwise moment is equal to the unknown mass MX times its perpendicular distance from that mass to the center of gravity, which is G, and that distance is X. Hence, we now say that 40 times Y is equal to 50 times 3. 40Y is equal to 1500, while Y is equal to 37.5 centimeters. Now, we are asked to record W. W is the distance from the end of the ruler, from the 0 cm point of the ruler to the point of the mass M, and is equal to Y plus 50. So W is equal to 37.5 plus 50, which is equal to 87.5 centimeters. Now, tabulating our results, we now say that when mass M is equal to 40.0, W is equal to 87.5 centimeters, Y is equal to 37.5 centimeters, and the inverse of Y is equal to 0.0267 per centimeters. Move over to the next stage. When M is equal to 50 grams, the same procedure is taken. And we have to recall that clockwise moments must always be equal to anti-clockwise moments. With that in mind, recall that we have already stated the formula that we use. M, which is the given mass, times Y is equal to M subscript S, the unknown mass, times X. So we can now say that 50 times Y is equal to 50 times 30. 50Y is equal to 1500. Now, solving for Y is equal to 30 centimeters. So the same thing happens. We'll find the distance of W, and W is equal to Y plus 50, which is equal to 30 plus 50, which is equal to 80 centimeters. So we compute our table of values. We now say that when M is equal to 50 gram, W is equal to 80.0 centimeters, Y is equal to 30.0 centimeters, and the inverse of Y is equal to 0.0333 per centimeters. We move over to the next stage. When M is equal to 60 gram, the same procedure takes place. For equilibrium to occur, clockwise moments must be equal to anti-clockwise moments. So with that in mind, and with our given formula, we will now forge ahead. Hence we will say 60 times Y is equal to 50 times 30. So 60Y is equal to 1500. So Y is equal to 25 centimeters. Then we will find the distance W. The distance W is equal to Y plus 50, which is equal to 25 plus 50, which is equal to 75 centimeters. Now, evaluating our table of values, we now have that when M is equal to 60 gram, W is equal to 75 centimeters, Y is equal to 25 centimeters, and the inverse of Y is equal to 0.04 per centimeter. Now we'll move over to the next stage when M is equal to 70 gram. So recalling that for equilibrium to occur, that the clockwise moment must be equal to anti-clockwise moment. So with the same formula bearings in mind, so we now have that M times Y is equal to M subscript X times the distance X. Hence, we will now have that 70 times Y is equal to 50 times 30. 70Y is equal to 1500. Then dividing both sides by 70, Y is equal to 21.43 centimeters. Now we go ahead to work out for the distance W. W is equal to 50 plus Y, which gives us 21.43 plus 50, which is equal to 71.43 centimeters. equal to change in the vertical axis all over change in the horizontal axis. So we have to take 2 points on the vertical axis, 2 points on the vertical axis, and then look for the corresponding points on the horizontal axis. So I have 70 minus 40 all over 0.0466 minus 0.0267, and simplifying, the slope gives me 1507.5 gram centimeters. Take note of the unit of the slope. So when we now evaluate the slope all over the distance x, which is 1507.5 all over the distance, which is 30, gives us 50.25. So we can see that this is equal to the mass of that unknown that we used for our practical. So that is what the evaluation gives us, the unknown mass m subscript x.